Thank you everyone for having me here. Good afternoon. So I will, I'll just give a brief background about myself. My name is Jyothis Indirabhai. I am the CEO of NetraSemi Private Limited. This is a company developing semiconductor chips for enabling AI in small devices and platforms. So this is primarily the system on chips for edge AI market. So I'll give a small presentation of what edge AI is, how that is progressing, what is the historic path to that, and what are the major challenges for adapting edge AI, and a bit of Indian context also I would like to touch upon. So coming to the edge AI. So the journey, first we will cover the journey part of it. So it all started when we had a prediction of IoT going to disrupt the industry. So this prediction happened almost 10 years back, where there were a lot of reports and predictions that IoT market is going to disrupt the world, just like internet and other internet and mobile phones, and likewise. So that prediction, when I read it in like 10 years back, I was thinking, what is this IoT, right? But now it is true. It is a multi-trillion-dollar market, and it is disrupting almost all aspects of sensors and automation around the world. So when IoT was selected as a disruptive technology, the edge AI was not, or edge AI or not even AI was there as a premium technology. So IoT, the way it was supposed to work was, there are huge number of sensors worldwide. They will be collecting data, and these are small amount of data. There will be billions of such devices around the world. They are all interconnected, and they are tied to cloud. So there is a big brain called cloud, and a huge number of DSP, or digital signal processing engineers. They will be analyzing this data, and they will make some decisions. So the original idea was, you create a billions of sensors, just connect it to internet, let that go to the cloud, and then there are smart brains who will be analyzing it and make some decisions and data out of it. That was a very good concept, and that was perfect, ideal 10 years back. Then what happened? Then there is a major change called AI. AI came into the picture. So why these experts? Why not computer make decisions based on the data? So that paved to a new brand of technology called artificial intelligence of technology, Internet of technology, Internet of Things. So Internet of Things became artificial intelligent Internet of Things. That means the central brain is going to do AI-based analytics rather than just like customized algorithms. So which was perfectly working fine. So this was the type of transitions happened in IoT, and today the IoT is completely in flux, where IoT is considered as AIoT, or even edge AI in most of the cases. So I'll come to that in the next slide. But before that, there is one more challenge happened in the IoT world. So where do this processing happens? Does it have to happen always in the cloud, or is there an alternative solution? Putting everything in cloud was the original idea, and it was extremely flexible, because in the cloud, it is a central place. Let us forget for now where this central place is, but at least you can put lot of machines into it, lot of servers into it. You can put lot of add-on cards into those servers, and then you can make this processing feasible. But then there is a problem. Is that the best methodology? Is this central place secure? And is there any privacy loss because of that? If the sensors are extremely high bandwidth or high data, is it technically feasible to send all this data to the cloud? Or Is it the response time? Is it like there is a constraint for that? Do we need real-time response? So the technical world started thinking about all these aspects. So the idea of getting everything done in cloud became almost impossible. So then there are evolution called on-premise computing, or like a distributed computing, where you don't do everything in cloud. The sensitive data or high bandwidth data is processed at the premise. So on-premise computing also happened to be the solution for that. That means a significant amount of computing still happens in cloud, but on-premise there are some servers who does the job. They will be directly connected to the terminal nodes like sensors, and then there is a hybrid computing model. But then again, that became totally, then it came to a lot of other aspects of design. That means you need two computing solutions. One is the premise computer, the server, and the cloud server. And then there are things like all these premises, all these sensors, are they all attached to the premise? Don't they need a movement, a mobility? So that is when an edge-based solutions came into place, where it can be on-device computing or on-premise computing, right? Rather than just a cloud-based computing. So these are the transitions happened in the industry. So let me come to the next slide, where the definitions I would like to, I mean, this is not a perfect definition, but let us come to that a bit more. So the IoT became AIoT, and today 85% of the market of IoT is AI enabled. So it is not a separate branch. Nowadays, AIoT is considered as mainstream IoT. So in the same thing, so the edge AI come to picture, where on-premise and on-device computing became extremely crucial, and majority of the applications today demand that. So let me ask you, I mean, to give like emphasize it to this point, if you look at many mainstream companies like Microsoft, Google, why are they making these chips? Why are they not following the traditional methodology of building solutions based on some traditional supply chains like chip makers? Why are they building their own chips for their LLM models and voice recognition and all those things, right? Alexa and those kind of applications. Why are they making their own chips? The reason is there is a major shortage of supply for addressing the edge AI market, right? So the edge AI, even though it is considered as one of the best solutions, considering the privacy, considering the real-time response, there are major hurdles to that for the widespread adoption, and that will happen in the next decade. So coming to one more exciting field coming up is autonomous things, right? So edge AI can be considered as on-premise, where it doesn't need to be a fully real-time response system. Consider the case of a drone which is going around and detecting mines. Do you expect that data to come back all the time to the premise or to the cloud? Not necessarily. So, or even for the navigation of drone or navigation of cleaning robot in a warehouse, what are the options you have for applying AI? You need on-device AI, which is going to detect the navigation, dictate the detection, recognition, and all those aspects, right? So that is why autonomous things is a major new domain coming out of edge AI, which requires real-time response, real-time detection, real-time recognition kind of activities, right? So these are the, this is how I kind of segment the whole area of IoT, where the edge AI and AIoT is almost synonymous nowadays. Coming to the market potential and adoption. Is it widely, I mean, we keep hearing edge AI for the last several years. Is it really there? I would say it is partially there, right? We haven't seen yet the full potential of edge AI, right? I will come to that point. So there are early adopters of edge AI and even AI, right? What is the how that early adoption happened? It's a kind of what is that? a lot of compromises were taken when you adopt Edge AI earlier, right? So there were not enough chips out there. So what was your option? Go and buy a graphics processor, which will be doing all this, capable of doing all this analytics, right? So it is available as a GPU or an FPGA, field programmable gate array. You just purchase one of them, create a product, like for example, a smart camera. You create a smart camera with a GPU. It works because GPU can do a lot of things. The question is whether it can do efficiently make it work. Not really. But so these are the constraints affected the industry. So industry, when they looked for Edge AI and AUT or autonomous things, there were not enough supply of platforms, right? So that is where the adoption of the Edge AI in applications is very slow today. But that may not be necessarily the case going forward, right? Different industries adopt this different way, but the potential is huge. So let me tell you the potential, right? How the Edge AI is changing the world. So traditionally the solution makers were very comfortable with the cloud-based solutions. So cloud was the center brain. Then Edge AI came into picture. Today or last year, it was, some of the market research tells that it was a 19 billion market, right? In the next 4 or 5 years, you are going to see it almost 5 times, 10 times. So it is one of the highest CAGR market in the world. It is growing 10x in 10 years. That is the kind of predictions we are seeing. You are already seeing the signs. The PC market is already changed to the AI PC. So Edge AI market is going to be much more than the cloud and server market within the next 1 or 2 years. That is the predictions, right? So the market is an extremely highly growing market. But again, semiconductor is the main ingredient which is missing there, or there is a big lack of the volume supply. So coming to the distributed computing. So basically, as I mentioned, there is 2 ways of approaching Edge AI, right? Many of the players just, Edge AI is good. Let us fix the problem because my customer demands privacy, right? Without the privacy, he will not take this solution. So there is 2 ways of adopting it. One is carefully architecting your design and your roadmap, right? That is one way of adopting Edge AI. The other way is just to go around, find out what is available, just to fix your immediate problem. So traditionally, because of various constraints, the traditional way of solving the problem is just fixing existing solution with an Edge AI alternative, right? But in a real business, it is always you can get a competitive advantage if you prepare yourself for embracing the Edge AI, and that's exactly what many of these big players I was mentioning earlier did. They are approaching Edge AI in a holistic manner, and I'll come to that in the next few slides, right? So this is, again, the same point. Different industries adopt it differently. The Edge AI, many of them still tend to use the cloud, a single cloud-based adaptation for AI. So what is the way forward, right? So let us look at the 2 aspects of it. One is the solution and application aspect of it, and then the platform and design aspect of it, right? When it comes to application, what are the things? You need to protect data. You have data storage issues. You have data scalability issues. You have system scalability issues. How to in a modular fashion, how you can scale the entire systems. And computational scalability, how you can scale up the computation infrastructure, right? These are the business problems of it, right? Of solving any solution. But on the right side, for the Edge AI, there is platform-specific issues, right? Platform is the utmost important part of Edge AI, rather than cloud. Cloud, it is just sensor. You find a way to connect that sensor to the cloud, right? But when you adopt Edge AI or a distributed solution, you have local computing. And what is the nature of that local computing? The local computing should be able to meet the power, performance, size requirements of your edge device. You cannot think of adding a 2 kilogram compute platform into a drone which is running, right? Or even into a cleaning robot. It's almost impossible, or it is not making business sense. So that is where a computational requirements in a very power and performance efficient platform, which can be scalable, which can be small weight, all these things are extremely critical. And those are the challenges Edge AI need to address, right? In the next slide, I'll cover how that is being solved today. So Edge AI Semiconductor, so this is where we are coming to, so this is where my company is also focusing on. So Edge AI it cannot afford to have traditional supply of chips. What is the traditional supply, or what is the supply chain look like few years back? We make chip, you build solutions. It was a very, very straightforward statement by some of these chip makers, right? We build chips according to our specification and our forecast of the market. We will create some chips, and that chip will be coming to you in 3 years. You design something for your clients. So that will not work for Edge AI. That works for semiconductor market, for the cloud and servers, because in cloud and servers, a platform addition means just plug in another platform, another kind of the blade into the server. But that is not true anymore. For the edge devices, you need to have the computing on the premise or on the device, right? So that changed the traditional computing methodology. The traditional computing methodology was putting everything into GPUs or some kind of high-end, high-power like AI processors. They are all in the cloud. You just build application. Don't worry about what is happening at the edge. But now you have to put everything onto that drone, onto that cleaning robot, onto that premise which is having a smart NVR or a video analytics platform. So here, what happens is the cost is extremely important, right? You are putting AI onto devices, though, so you cannot afford to have a like 1 crore smart camera or a 50 lakh smart camera or even 2 lakhs smart camera. All these things may not be affordable if you plan to put millions of cameras in the street or millions of occupancy monitoring cameras in each room, or even conference room monitoring, or even, for example, like shelf monitoring in retail, right? All these places you cannot afford have expensive chips sitting in the devices, right? So the traditional way was GPUs, because GPU, even though it was originally designed for graphics processing, it is suitable for AI. So people, yes, let us add like 10 more blades of GPU into the server, we are done. That will not apply for edge processing, right? So that is where new family of edge chips coming into the market. Today, if you look at it, there are the whole industry is actively ramping up for new semiconductors for edge AI. What are the challenges? You need to, each domain require its own domain-specific requirements. So when you put a single chip solution for the edge devices, it needs to solve a lot of things, not just AI. If it is a camera chip, it needs to have computer vision, it needs to have image signal processing, it also needs to have AI. So AI is not now just another big piece you add to the blade. Instead, it is going to be along with your system on chip. It does the job in a very cost-effective and computational efficient and power efficient manner. So these are the things which are driving the new chip designs, and we are fortunate to be part of this league of chip makers who are designing for edge AI, right? So coming to, so that is all about, so the future of edge AI, right? So as I mentioned, the cloud edge hybrid models are already there, and then IoT solutions are ramping up. So it will be almost a norm for the next 5 years. You will see a lot more cleaning robots, the robots, different kind of robots, military robots, and all those things are going to be enabled with autonomous capabilities, navigation, etc. And power efficient neuromorphic computing is a major area where even own memory computing, and there are new chip design methodologies are evolving for enabling new way of AI making. And then data efficiency in AI. I mean, even though like many of the coding or the AI solution makers today do not have any constraint. They can design whatever AI models they want. They can put it in the cloud. Cloud will do the job. But when you design it for edge AI, it need to be extremely data efficient. It has to have very thinner models which can run on the platform. So you are not designing for the cloud. You are designing for a resource constrained platform. So that is going to be a new challenge for the edge AI market. Challenges are always opportunity, right? So that means new league of engineers need to evolve to make it efficient for edge market, right? So distributed computing also comes with the blockchain enabled, like for the data security and all those aspects. So there are various aspects of edge AI are evolving nowadays. So India, right? Where are we standing, right? So let me come to this point very importantly. So IoT, even though it was predicted 10 years back as one of the most disruptive technology of the coming times, how India reacted to that? We created some courses. We sent some people again to US, and we did some. We actually embraced the service model, right? Which is not bad. We got some jobs, but I would say IoT was a lost opportunity for India, a multi-trillion market going to evolve, and we did not do anything about product making. It was a very easy market to get into, creating products, creating solutions, solutions powered with the products. So solution by itself in IoT world has no meaning. You can always create some SaaS platform and put it somewhere, right? But in IoT, it is a hybrid model where platform and the solution make, if it goes together, it is extremely valuable in the market, right? Unlike a server-based model. So that best we missed, where we missed creating low cost and low complexity chips for the IoT market. We missed making extremely low complex, high volume products for the market. And when you didn't make products, naturally your solutions became extremely inefficient and you became service engineers, right? So that's what happened to India in the IoT space. So coming to the next big wave is edge AI. The IoT is going to be redefined by the edge AI. So this is a new opportunity for India, new opportunity in semiconductor making, new opportunity in efficient products, because all these new edge AI enabled products are going to be made. They are not made. So Indian product companies have great opportunity here, and how that great opportunity can be utilized. Can you expect Chinese chips to be here and you can make the products? No, China is not going to sell those chips to you. So figure out yourself. A great amount of partnership needed, great amount of R&D needed to optimize those solutions. So that is how Indian companies can make use of this opportunity. So one more product opportunity made available for India, and let's see how India as a country respond to that opportunity. So how you can build an ecosystem. So I'm just coming to a solution. I don't know how acceptable this to the Indian industry, but a edge AI solution. Okay, of course you can always create the cloud part of it and create a SaaS model for that. But if you want to completely create a USP for your product and solution in the market, you need to have tie-ups. You need to have tie-ups with the semiconductor makers. You need to have tie-up with the platform makers. You need to have tie-ups with the SaaS and the final product delivery folks, right? So an ideal solution is India, if we don't want to miss this buzz of edge IoT and AI, we need to act very efficiently, create the ecosystem, create the supply chain, create the chips, create the products behind those chips, and the solutions around that. That way we can actually make use of this particular opportunity, which is extremely huge because it is a new industry in the making. So with that, I conclude. So this is what we carry. I think the next war is going to be fought on chips, right? The semiconductor is actually the new war today. If, I mean, to emphasize the point, I am just telling you, if China takes over Taiwan today, the world is in recession for the next 10, 15 years, right? So just imagine that. So that is, I mean, Edge AI together with the chip market, the Indian government is putting a lot of emphasis on the semiconductor market. It could be a good opportunity for the solution and product makers also to grab that opportunity. Otherwise, those chips will be sold in US and China and the other markets, and products will still come back to us. So that with that conclusion, I'm actually stopping here. Thank you. And if there are any questions, I can answer that here. Thank you.